I'm going to show you a very, very fascinating ad. And this ad is from 1997. And I'll show you the attack. Is Ronen here? Ronen, are you online? No. Ronen is going to be watching the video and is going to say, if I was only online, I could have participated in the discussion. So, the year is 1997, and people are watching pay TV. And people get these smart cards, and they want to watch all the channels, but the smart card only allows them to watch, let's say, 5 channels. How is this implemented in 1997? There is there's like a table in the memory of the smart card that says this channel 1, this channel 1, this channel 0, you can't watch it. You can watch this and this and this channel, and you can't watch all the other channels. What do? I want to watch all the channels. So what can an attacker who wants to watch all the channels do? What would you do as an attacker? Do you hear the cat purring? So it's like what you want to do if you want to watch all the channels, you're just going to put you're going to put like a memory programming device, and you're going to change all the values in the table from 0 to 1, and then you can watch all the channels. Fantastic, right? So people were doing this, and the pay TV companies weren't happy with this. So what they did is they added an integrity check. So when the device wakes up, it reads all the memory and it does some kind of integrity check. It calculates a very secure, as secure as possible in 1987, integrity check over all the bits of the memory. And then if somebody modified this table, of course they broke the integrity and the device is going to refuse to run. How is the device going to refuse to run? This device doesn't exit. What it's going to do is it's going to get stuck and in an endless loop. So the program is, the chip is booting, it's checking the integrity. If the integrity is failed, it's going to get stuck in an infinite loop. And if it passes integrity, it's going to continue serving all the channels. So thus was born the device called the Unlooper. And what is the Unlooper? The Unlooper is a device that takes a smart card which is failing integrity check and stuck in an infinite loop, and it's going to get it out of the loop. And once it's out of the loop, we can watch all the channels. Hooray, we're very happy. Okay. So this is an ad for Generation 5 loop. I just want to say that the word Unlooper got like stuck, and there were there's like a cat and mouse game. The pay TV companies added other countermeasures, but these devices got stuck in the name of Unlooper. So this is a Generation 5 Unlooper. It is guaranteed to outperform any other Unlooper, and it uses the Atmel, and it's using Wild Thing, Cardmaster, Terminator, and T5, and it fixes card fixes. That we need to fix the card. It was broken. It wasn't letting us watch all the channels. And it doesn't have any bugging. Yeah, it's a wild type. It's a really, really cool Dragon Landing Unlooper. So let's try to analyze what is the taxonomy behind this Unlooper. So first of all, what is the method? I'm going to tell you what the method is. The method is that there is an external clock to the smart card, and this Unlooper is counting the amount of machine instructions until the time where the smart card is inside this verification failed, I'm stuck in a loop. And when it gets to this precise time, it's going to give a clock glitch. So this is a clock glitch transient control time. So after I give this glitch, Yeah, they did reverse engineering, and the question is, how did they do reverse engineering? Very, very dirty business in the pay TV industry. Very, not everything can be told about it, but I think there was a book. There was a book. I think there's a book. So let's say that the vice head of the Shabak was involved in it. Very crazy stories in the crazy days of pay TV industries. But after you do this clock glitch, of course, you want your smart card to keep running as regular. So it's a transient chip, and you have to get control over the time. And what is the target here? What is the target of the attack? The target is the control flow. It's the instruction processing. So we attack. The target is no, it's not the system clock. We provide the system clock. You can. That's an idea. So the method is a clock glitch, and the target is the instruction processing. So again, the attacker has the method, and the victim has the target. So the target is the instruction processing. So this was in 1997, and you can see this is the Unlooper. See how it looks, and maybe if we zoom in a little, this is where you put in the smart card. You see, this is very, very old technology. This is like a serial port and switch. I won't have time to discuss BM Shamir with you, so I will just give you a little puzzle, and you can think about it yourself, and you can just read BM Shamir. And my puzzle is the following. It's like a little motivation for BM Shamir with that LED. I have a bunch of devices, devices with an identical key. And these devices are encryption oracles. I give them plaintext, and they encrypt under this plaintext. And all of these devices have the same, let's say, 64-bit secret key, 64-bit. So if I want to brute force these devices, how many queries will I need? Two to the power of 64, exactly. 2 to the power of 64. Well, 64-bit. I can just send, I send a plain text, I get the ciphertext, and they have the spare, and I'm going to try all possible 64-bit keys and see which one gets me from the plain text to the ciphertext. So this is a lot of work. And now let's imagine I have a fault attack, a destructive fault attack. And this fault attack zeroes out the lower 32 bits of the key. So once I do this attack, the key is going to stay, the top 32 bits are going to stay the same, but the bottom 32 bits are going to be 0. And I'm telling you that if you have this fault attack, you can find out the key in 2 to the 32 queries. O of 2 to the 32 queries. How do you do this? You can think about yourself. And this could be a motivation to BM and Shamir's fantastic work, which extends this in a very, very wonderful way. You can think about this at home. Next